Today, we're peeling back the layers of the software you use every single day. And we're going to reveal an unseen battlefield, the world of application security. It's this constant push and pull between the people who build our digital world and, well, the people who try to break it.
And it really all boils down to a single kind of mind-bending question. How can something as tiny as a single quote mark, just one character on your keyboard, be powerful enough to completely bypass security, crash an entire app, and leak the private data of millions of people? It sounds totally impossible, right? Well, stick around because you're about to find out exactly how it's done.
So, how do you win on a battlefield like this? Well, it all starts with a core philosophy. You don't just go around patching holes after the fact. No, you build a fortress from the very first stone. It's all about being secure right from the start.
For the longest time, software was built with one primary goal in mind. Does it work? Functionality was everything. The problem is that approach left the door wide open for countless attacks. The modern way, what we call the Secure Software Development Lifecycle, or SSDLC, it asks a much better question. Is it unbreakable? Security isn't just some feature you tack on at the end anymore. It's about weaving it into the very fabric of the application, from the first line of code to the final launch.
Now, to build a really strong defense, you first have to know your enemy. So, let's pull back the curtain and meet the villains of our story. We're going to see exactly how they operate and break through those digital walls.
Our first villain is a true master of deception. It doesn't use brute force, it tricks an application into running hidden commands for the attacker. Its name is SQL injection. And yep, this is the culprit behind that single character takedown we talked about.
So what exactly is a SQL injection? Okay, think of a database as a super literal librarian. Normally, you go to the website's login form, you fill it out, and you're basically asking the librarian for a specific book. But with a SQL injection, the attacker scribbles a new instruction on that request form. Something like, or you could just give me the keys to the entire restricted section. The application, not knowing any better, just passes that sneaky note along to the librarian, the database, who reads it and, being so literal, just follows the command.
It's really a simple but devastating three-step dance. First, the attacker slips a little piece of carefully crafted text into a normal input box, like your username field. This isn't just gibberish, it's designed to break the logic of the command the app sends to its database. And the result? The command gets rewritten in a way that just bypasses the password check entirely, tricking the database into handing over all its secrets.
And this right here shows you the trick in action. It's brilliant, really. A normal login check looks for a username and a matching password. But look what the attacker typed in. That first single quote, it closes off the username field early. Then they add or 1 equals 1, which, as you know, is a statement that is always true. And that double dash at the end, that's a comment. It tells the database to just ignore everything that comes after it, including the password check. So the database is no longer asking for a specific user and password. It's asking, find me a user where the name is blank, or where 1 equals 1. And since 1 always equals 1, the database goes, sure thing, and bam, it hands over the entire user list. Mystery solved.
Okay, so if SQL injection is the sly trickster, our next villain is just a brute. It doesn't rely on clever logic. It uses pure, overwhelming force to just smash its way through an application's memory defenses. And we call this a buffer overflow.
So how does this work? Imagine a program's memory is like a row of drinking glasses on a shelf. A buffer is just one of those glasses, and it's designed to hold a very specific amount of water, or in this case, data. A buffer overflow attack is like taking a fire hose and blasting way too much water into that one glass. It overflows, right? And that water spills into the glasses next to it. Only it's not water, it's malicious code spilling into adjacent memory spaces where the program might accidentally run it.
And this is not just some theory. The most famous or infamous example of this was the Heartbleed bug, a tiny little flaw in the code of OpenSSL. The very software meant to keep us all safe online created this massive vulnerability. It got in there in 2012, and nobody found it for 2 whole years. For 2 years, it was silently leaving a huge chunk of the internet's secure traffic
completely exposed. 64 kilobytes. I know, it doesn't sound like a lot, but here's why that number is so terrifying. With just one single malicious request, the Heartbleed bug could leak that much of a server's live, active memory. And what's inside that little chunk? Potentially the crown jewels. User passwords, private encryption keys, basically everything an attacker needs to impersonate that server and steal data.
So, we've seen how attackers can trick and smash their way into our systems. It's a bit scary, I'll admit. But don't worry, because the defenders, they have a powerful toolkit of their own. Let's take a look at how they fight back.
The first most fundamental rule of application security is simple. Never ever trust user input. Period. So the most basic defense is called input validation. Think of it like a really meticulous security guard standing at the application's front door. When a malicious request like this one comes in, trying to sneak its way into sensitive system files, that guard immediately spots the danger signs and just rejects it outright.
But of course, attackers know about these security guards, so they try to put on a disguise. What you're seeing here is an example of that. This gobbledygook of characters, it's really just a secret code for the same malicious path we saw before. A lazy security guard might miss it, but a really secure system knows how to decode these tricks and see the attack hiding underneath.
So how do we stop that SQL injection trickster for good? Well, there's a silver bullet, and it's called parameterized queries. This is the direct counterattack. It works by creating a hard separation between the command and the data. The application essentially tells the database, hey, here is the command I want you to run, and then separately it says, and by the way, here is the user's data. The database now knows that the user's input is just plain old data. It should never be treated like a command. The trickster is completely and totally disarmed.
But you know, good security is all about layers. It's not enough to just block one type of attack. You have to protect the user's entire journey. That means using things like long, random session IDs that can't be guessed. It means automatically logging people out when they're inactive, so no one can just walk up to their computer and take over. And, maybe most importantly, requiring multi-factor authentication, or MFA. That one step makes stolen passwords so much less useful to an attacker.
But here's the thing. This battlefield, it's always changing. As new technologies like artificial intelligence become a part of our daily lives, you better believe new threats are popping up right alongside them. One of the most fascinating and, frankly, terrifying new threats is something called data poisoning. You know that AI and machine learning models learn from looking at huge amounts of data? Well, this attack involves an attacker intentionally feeding them bad, corrupted data while they're in that training phase. It's like trying to teach a child vocabulary, but you're deliberately giving them all the wrong definitions for words. The AI learns the wrong lessons, and its trustworthiness is just destroyed from the inside out.
And this isn't just science fiction. These are very real concerns that experts are grappling with today. Imagine poisoning the data to make facial recognition systems identify the wrong person, or manipulating search results on a map, or get this, training your spam filter to think that dangerous, malicious emails are actually safe. The very trust we're supposed to have in the AI's decisions becomes the target.
Okay, we have covered a huge amount of ground, from classic attacks all the way to threats of the future. So before we wrap things up, let's do a quick knowledge check to see what stuck.
All right, first question. What do you call the attack where hackers take usernames and passwords stolen from one big data breach and then just try them out on a whole bunch of other websites hoping for a match?
That would be credential stuffing. It's a super common attack because, let's be honest, so many people reuse their passwords across different sites. It's a numbers game for the attackers.
All right, so here's the last and maybe the most important point. We've looked at the battlefield, we've met the attackers, and we've seen the defenses. Application security isn't just a problem for developers. It affects every single one of us. So now that you understand these threats, it's time to ask yourself, what is the weakest link in your own digital life? Because answering that question, well, that's the first step to becoming your own best defender.